Hello Tech Spinners, my name is Glenn Wright and I'm here to show you more about the Visual Spinner 3D editor. In my last screencast, I used the editor to model the first few seconds of Ben Drexler's comborific routine. That was several weeks ago, and since then I've made quite a few improvements to the editor's interface, and I'm ready to show them off by modeling more of Drexler's routine. Just as a review, in that last screencast, I showed you how to add new segments of movement, how to modify those segments by dragging the head and handle nodes, and how to do things like add anti-spin and change the acceleration using this control panel. Also, I showed you how to save and restore JSON routines. So I'm going to start out, first thing, by restoring the JSON file that I saved at the end of the last screencast, which looks like this and covers the first few seconds of Drex's routine. Right up until about here. So this is our starting point for continuing on. Now, as we click through, we can see that the next little movement is almost an exact repeat of the first one, except with a little transition at the end. So we can copy parts of this routine simply by dragging and dropping segments of movement like so. Okay, and then this little segment is different, and we can fix that just by dragging the nodes like so. So now we have another little pendulum hybrid that ends with this transition. Okay, so for the next move, Drex uses one of his point ISO transitions, which are from his tech video number 390. And then he goes into an isolation versus vertical cat-eye hybrid, which he has a tutorial for. And notice that this move is pivoted slightly to one side of this body. That's going to be important later. So we can set all this stuff up by adding new segments of movement and by dragging the moves like so. Okay, now at this point we can hit play to take a look at what we've created, and we can see we have something that kind of more or less looks right. The way things line up are a little bit janky, but we can tell what it is that's supposed to be going on, and if we don't mind that too much, and we don't want to be bothered learning some of the advanced features of the editor yet, we could stop here. But what I'm going to show you next is how to use the shoulder node to make this move look quite a lot better. Now, in order to understand why this move doesn't look as good as it could, we need to talk about the shoulder node. As I mentioned before, the shoulder node doesn't necessarily have anything to do with Drex's actual shoulder. It's just a way of thinking about how we can pivot a move off to one side or the other. And while the first few pendulum hybrids are centered horizontally on Drex's body, and they look the way they're supposed to, the next hybrid is pivoted off a little bit to the left, to his left, or to our right. And it's going to look better if we model that by dragging the shoulder node over to where it's pivoted. So we can do that by dragging this little diamond shape over to where we think the pivot point should be. Now, for this little transition, I'd say it's pivoted about half a tether's length to one side. And a little tip of convenience here, normally if you drag the shoulder node, it's going to move the handle and the head node as well. But if you hold the control key, not only will it bring the shoulder node to the top where you can see it more easily, but you can also drag it independently of the other two nodes. And then once we get to this actual cat-eye versus isolation transition or hybrid, we're going to have it pivoted one full tether's length off to the right. And who knows, I may fast forward through this part as well. Now this is a little bit tedious, but it would actually not be quite this tricky if in the first place we had dragged it off for the very first move, because then when as we added new moves to the end, they would have been created with the shoulder node in the correct place. And we wouldn't have to do all this manual tracking. Okay, now let's take another look. So at this point, there's still a few things that don't line up quite right, but for the most part, this isolation versus cat-eye hybrid looks just about perfect. And again, at this point, you could decide that if you don't want to learn any more new features, you could call it a day. And I honestly wouldn't blame you, because the feature I'm going to show you next is a bit advanced. I'm going to show you how to use custom transition points to make the move look just about perfect. And to be perfectly honest, I think people are going to find this part confusing. It really does take some practice to get the hang of it. On the plus side, I'd like to think that it does teach some valuable ways of thinking about tecpoi transitions. So in order to make a custom transition point, we click on the little white circles between the move segments, like so. Now if we click here, well, let me put it this way. If we click on this first move before it, we see the ending position for this little segment of movement. If we click on the next move after it, we see the ending position for this move. When we click on the transition, we actually see the beginning position for this move, which needs to line up the head and handle with the ending position of this move, because the head and the handle are physical objects and they can't teleport. But this shoulder node that is sort of an abstraction showing how we're pivoting the move actually can change, and that's going to be a little bit confusing. But what that basically means is we're going from thinking about the move with a head and handle right there to that's centered on the middle, to those nodes being in the same position but centered a little bit off to about half a tether's length off to the right. And then after these two segments, we go ahead and change it so that this that's pivoted one full tether's length off to the right. And I expect this is a little bit confusing, but as you can see when you watch the video, it all of a sudden looks a whole lot smoother. And we can go do the same thing over here when the pivot changes. It goes from being right there. We just snap it over right here a little bit. And there we go. Once again, just about perfect.